Good morning, class. We are looking at Calculus 1, Chapter 1, Functions and Models. And starting with the first section, 4 ways to represent a function. In this chapter, we cover 4 ways to represent a function, mathematical models, new functions from old ones, exponential functions, and logarithmic functions. When we look at a function, there are various ways of approaching it. We can do it verbally, numerically, visually with a graph, or algebraically. As you all have seen, when we have a function machine, x, and then f of x, and then the f function results in f of x. The result is a combination, a set of pairs, x comma f of x, where x is the independent variable, and f of x, y or f of x, normally, is the dependent variable. One of the things we use is a vertical line test to see if we are dealing with a function, okay? And a function is considered increasing, in short, when x goes up, so does y, okay? And that would be the definition of a increasing function. So I'm thinking the easiest way to look at this concept would be to look at when x increases, y increases. This is an increasing function. And when x increases, remember, as we go from left to right, x increases. And what happens to the y? If y decreases, then we say it's a decreasing function. So that's as far as the basic concept is concerned here. Okay. All right. Let's actually, start with you to make this work better for the recording. All right. So that's as far as functions are concerned. The other definition is an even function versus an odd function by definition. F of minus x equals f of x. That is the definition of an even function. And f of minus x equals minus f of x is the definition of an odd function. Nothing brand new. You've seen it. They're just refreshing your memory. And here's some examples as to why we need a function, okay? If we are interested in geometry, the area of a circle as a function of the radius. The human population is a function of time, so on and so forth. So we are repeating the 4 methods, and we are mentioning why we need that. Now, something that you've seen, and it's not brand new, everybody remembers, when we look at the concept of a function, there are some basic definitions, hopefully everybody remembers. First, as far as definition of a function, the easiest and simplest way to define a function is that if you're looking at a set of pairs, simply the x coordinate, meaning the independent variable cannot repeat. The independent variable cannot repeat. That's really the idea, and that's why we had the vertical line test, if you remember. Now, if you look at those pairs, we have the first coordinates known as the independent, okay? And if we put them all together, we call them the set of domain. And we have the second coordinates, okay? The dependent variable, normally y or f of x, that's called the range. So we have independent variable, dependent variable. Independent variable is the first variable, doesn't have to be x, but many times that is the case. Now, if you're looking at this example, we should be able to read and tell what's going on, okay? I want you to pay attention to the top right graph. The top right graph shows you the domain and range. So when you see a graph, the portion covered along the x-axis is the domain of the function. The portion covered along the y-axis is the range of the function. Okay, it's very straightforward. That's why you should be able to answer these questions now easily. You're looking at the graph on the right side. You want to find the values of f of 1 and f of 5. Okay. Now, along the x-axis, you look for 1. Along the y-axis, you look for the y-coordinate of that. That becomes f of 1. And I hope everybody can easily see what point we are referring to. That point has the y-coordinate 3. Okay. I'm looking at this point, and this point has x-coordinate 1, and y-coordinate is 3. Let me use a different color here, class. So now when I'm looking at f of 5, okay, then I'm looking at this point. As you look at this point, the x-coordinate is 5. Let me just write 5, obviously 5, right? The x-coordinate is 5. What is the y-coordinate? You do your best to read, okay? It's negative 0.6, 0.7, whatever you read, I'm not, too worried about that. The fact is, we know what it is, roughly negative 0.7. If you read it slightly different, it's not a big deal, okay? So, what is the domain? Well, this covers anywhere from here to here. So along the x-axis, we go from 0 to 7. Okay. Along the y-axis, notice that this point covers this point, and the top covers this point. And that is our range. Okay. So domain from 0 to 7, range from -2 to 4. By the way, one might write this one as x is between 0 and 7. It has exactly the same meaning. So I hope everybody's following that, whether you write a set builder or an inequality, okay? So this is an inequality class, inequality. This one is known as a set builder. And this one is known as interval format. Okay, so whatever the case might be. All right. I hope it's straightforward. Now, vertical line test. Everybody remembers that we use a vertical line test to see whether a graph represents a function or not. Okay, it's very straightforward. Why is that? Because when you look at the equation of a vertical line, x equals a number, for example, x equals a. I hope everybody remembers that. So every line represents a function except a vertical line. In fact, it can't get any worse because x keeps on repeating. Okay, so that's why we use that to see whether one represents a function or not. And as you can see, the first one is, the second one isn't. Okay. Now, does this represent a function? Obviously, the answer is not, because those 2 points okay, have the same x coordinates as an example. Okay, but we can cut that into two pieces if you recall. Okay, there is a way around that. For a case like this, remember parabolas that open sideways. You can cut it in a half. The top half is a function, so is the bottom half, okay, in case you want to do that. All right, here's a function given known as a piecewise defined function. What is a piecewise defined function? When a function is defined in different subintervals differently. If you look at the first part, f of x equals 1 minus x, in short, what this means, you can call it y or even y1. The first portion is this line. You can graph that. This second portion, okay, and I'm going to put it up here, class, y sub 2 plus x squared. So in essence, you really have two functions. One of them is a line, 1 minus x, and one of them is a parabola y equals x squared. You put them together, okay? Now, as far as the graph is concerned, just you know, and we'll do it later on. As far as the graph is concerned, the idea is very simple, okay? Remember, 1 minus x is the same as y equals 1 minus x, the same as y equals minus x, shifted up by 1. So this is one of them, okay? But this is good all the way to negative 1. So if you look at this one as negative 1, so it's good up to here, which means, use a different color. This portion is not good. The portion in red shouldn't be part of the graph, okay? That's the idea. The whole graph is there, the portion. So it's a good practice that you graph the whole thing and then erase the part that it shouldn't be in the first place, okay? Now, if you were to graph, different color here. If you were to graph the second portion, y equals x squared, looks something like this. This is not to scale by any means, class. Probably the worst graph you've ever seen. Okay. However, it says when it's larger than negative 1. And by the way, let me just go back and fix something. Okay. And that is, I see the equality here. So that means this is solid, everybody. So this point is solid because I see the equality. Okay. Now let me use a different color, red. Now the second one, when it's larger than negative 1, and remember this is negative 1. So from here, it's no good up to here. But what about the end point? Okay, the end point is either a hole or solid. Because I don't see any equality, it becomes a hole. So that's really the graph. Of course, I will show you the graph, which looks better than this in a moment. But the bottom line is, this is how you graph it. It doesn't take long. In any event, the next one is asking, so that I'm going to erase this. We will see this again, class, with which looks a lot better than this. So we want to find f of negative 2. So the point is you use the top portion or the bottom portion. Because it's negative 2, okay, you use the top portion. We want f of negative 1. Negative 1 has the equality for the top portion. So again, you use the top portion. Again, you've seen this stuff. It really should be boring, okay? And finally, f of 0 belongs to the second portion, okay? And I have already mentioned the graph. This is obviously a much better graph than I gave you, but I think it's pretty straightforward, okay? So that's a graph of this piecewise defined function. Okay, everyone? everybody remembers the absolute value function is a V shape. So we all remember the definition of it. By the way, absolute value simply put is distance, okay, from zero, distance from zero. And so absolute value of A is 8 if A is larger than or equal to 0, otherwise negative. Okay? So you do the same thing here. You want to graph this, you are graphing two pieces. So the first piece, y equals x, the second piece, y equals negative x, and you cut it into two pieces, paying attention to the restriction that is given to us by the domain, okay? And so if we just pick up a few examples, okay, we're just making up some numbers, okay? Now this one, this last one, I just want to make a point, and the point being, remember, we are making up numbers. What is 3 minus pi, okay? 3 minus pi is roughly negative 0.14. But in calculus, we want to go with precise answer. Remember, pi is 3.14159, and it continues indefinitely. Okay, it's an irrational number. And so in calculus, many times we are interested in the precise answer. So it's pi minus 3 if we want to go with the precise answer. And the graph, as simply put, is what? Is a V shape with the vertex at the origin. All right. We are looking at a function that is called a step function. The reason it's called a step function because it literally looks like a step. There's a jump. So it says, consider the cost, C of W. W stands for the weight of mailing a large envelope. Okay, with weight W. From 0 to 1, they charge us 0.98. And again, I'll show you the graph, but I just want to make a point, even if I don't show you the steps with details, just looking at what's given. What it really means is, if you're looking at this one, from 0 to 1 along the x-axis, the y-axis is 0.98, but 0 is not included. So just that part, I want to make sure, okay, I want to just show you that part. So this is 0 class, okay, this is, let's say, 1, and this is, let's say, 2, okay? So if I'm looking at the first one, and this is being represented by W, and this is being represented by the cost, okay? So if I am looking at, let me use a different color. If I'm looking at just the first portion, along the x-axis, and let's also write this one as, I'm going to write this one as 100, that means 100 cents class, okay? So 100 cents or $1, okay, 1.00 or 100 cents, whatever you want to call it. So along the x-axis, I'm looking at this portion, okay? This is along the x-axis. 0 is not included, 1 is included. So what would be the graph? Okay, let me use a different color. Just for this portion, nothing else. For this portion, okay, starts from here. By the way, this is now 98 or 0.9. And it goes flat all the way to 1. So the graph for that portion is what you see. And then it jumps from 1 to 2. So on and so forth. That is the idea behind the graph. I hope it's making sense. But again, I want to show you a better graph class. So let's actually erase this, show you a better graph. but I hope that was straightforward. So with that being the case, you can write it's 0.98 from 0 to 1. 0 is not included, 1 is included, then it becomes 1.19, so on and so forth. This is the graph, and this is called a step function. This is called a step function class. Okay, so I hope it is straightforward. Okay, there's really not much to it. So I hope we are comfortable graphing something like this. Okay, step function. The next thing is the idea of an even and odd function that was discussed. The synopsis of the core section is given in the beginning. So what do we mean by an even function? What do we mean by an odd function? A specific definition, f of minus x equals f of x. Okay. And so f of x equals x squared is even because you go through the process and you can prove that. Okay. And a function is considered even if it's symmetric with respect to the y-axis. Okay. An example of an odd function is y equals x cubed. So you evaluate f of minus x, it ends up being minus f of x. And the graph is symmetric with respect to the origin, okay. Or rotating it 180 degrees about the origin. So an even function is symmetric with respect to the x-axis, okay. Symmetric with respect to the x-axis class. Okay, whereas an odd function is symmetric with respect to the origin. So I hope that is straightforward. Okay. So having said that, let's look at this simple example. What's going on? Are we dealing with odd, even, or neither? It's very simple. You have to go through the process and work it out, class. All right. So part A, okay, you evaluate f of minus x. So let's see what happens. When we evaluate f of minus x, we get minus x to the power of 5 minus x, which is the negative of the parentheses x to the power of 5 plus x, which is the negative of f of x. And that's a proof. We just proved this is an odd function. Okay, class, this is an odd function. Part B, we look at g of negative x, 1 minus negative x to the power of 4. Because the exponent is even, it remains unchanged. It is identical to g of x, therefore it is an even function. Okay. We do the same thing for c, h of minus x. And we simplify. We get negative 2x minus x squared. So what's going on? It doesn't look like h of x. Okay. So it's not an even function. It doesn't look like negative h of x. So it's not an odd function either. So it's important to see what's going on here. Odd, even, or neither. Generally speaking, when it's a combination of the two, it's neither. All right, increasing and decreasing was discussed. Okay. In short, x, as we go from left to right, x gets larger. What happens to the y? The y gets larger, increasing. If it doesn't, if it gets smaller, it's decreasing. Now, one of the things that I want you to pay attention the way I have it here. This is the way the text goes for it. The endpoints are included. Many authors are against that, and I like to mention that when you do your homework, exam, quiz, just follow so you get full credit and see how they want you to answer. But the reason the endpoints we don't know what's going on, because really before you make a decision about the endpoints, you have to know what happens next. And that's why the endpoints, for example, if you look at B, at the point that B is there, is B increasing or decreasing? Okay, if you read this, the function is said to be increasing from A to B, and then it's decreasing from B to C. B is both increasing and decreasing. The point B itself. That's why it's a good practice to use parentheses. Anyways, here's the definition. I'm repeating the definition. And here's an example that we want to answer. Given the function f of x equals x squared, where is the function increasing, decreasing? It's a simple graph. Everybody knows that. I wouldn't worry about that. I'm assuming everybody remembers that. Okay. So with that being the case, okay, with that being the case, you can clearly see where the function is increasing, where the function is decreasing. The function goes from negative to positive infinity, from negative infinity to 0 is decreasing, from 0 to infinity is increasing. So pay attention to my notation. I don't like to include the 0 in any of it, whereas your text does. To get full credit for your homework, you probably want to stick with what your text does. Okay, I can't repeat this enough. But generally speaking, the end point is what? Is it increasing or is it decreasing? If you include that in both cases, notice the first one says it's decreasing and the second one says it's increasing. So it's doing both. That's really not a good practice. In any event, here's the graph. We want to determine whether the curve represents a function, and we want to come up with the domain and range. Okay. It's a very simple case. It's obvious to everybody that this is a function. Why is that? Because it passes VLT, short for vertical line test. There is no vertical line you can come up with that crosses the graph more than once. Therefore, yes, it represents a function. Now, as far as the domain and range is concerned, so this point, and then I'm looking at this point, along the x-axis what we cover, this much, okay? So we cover from -2 to 2. Let me use a different color. That is for the domain. Let me use a different color for the range. For the range, okay, this point will cover this point, and then this point covers this point. That's our range. So I hope you realize how easy we can come up with the domain, range, and why this represents a function class. Okay, very straightforward. All right, spherical balloon with radius r inches. In fact, maybe somebody can read that for us. Anybody feels like reading this question for us? Because I'm sure you're tired of hearing my voice. Class, anybody want to read for us, please?
I'll go ahead and read it.
Sure.
So a spherical balloon with radius r inches has a volume V of r equals 4 over 3 pi r cubed. Find a function that represents the amount of air required to inflate the balloon from a radius of r into r plus 1 inches.
Thank you so much, Talha. Okay, very straightforward question, class. One of the things that you need to know from geometry is the volume of a sphere is 4/3 pi r cubed. Okay, everybody, the volume is 4/3 pi r cubed. So having said that, okay, we want to know what happens as we go from r to r plus 1. So simply put, we calculate the v at r plus 1, subtract from it the v of r. V of r is given 4/3 pi r cubed. Now replace the r with r plus 1 also. So v of r plus 1 minus v of r, okay? And basically 4/3 pi times now r cubed, that means r plus 1 cubed, okay? So this part would be 4/3, okay, pi r plus 1 cubed. That's the idea, okay, class? And you do the math, you simplify, and that becomes your final answer. The only thing that I want to add, okay, r plus 1 cubed, I hope everybody knows how to do that. Basically, you recall a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed, right? So you can use that to simplify this. Okay, that's pretty straightforward. Okay, class? For an example like this, I put that just as an example for you. I really don't want to go through that because it's very straightforward. Just as an example, when we say f of 2, that means replace the x with 2. When we say f of negative 2, that means replace it with negative 2. And everybody can, handle that. I wouldn't worry about that. I'm sure you know how to do this. But I am giving you the answer here, okay? And I highly recommend, if you have any doubts, try this on your own, making sure that you can handle it. For the sake of argument, if you are interested in f of negative 2, it means 2 times negative 2 squared minus x is negative 2, and then plus 5, okay? And so that convince yourself you can add them up to 50. Okay, that's the idea. I set this up. F of a plus 1 means 2 times a plus 1 squared minus x is replaced with a plus 1 plus 5, and we should be able to simplify it to, that as the answer. So I hope it's very straightforward. There's really not much to it. All right. Find the domain of the function. If you recall, when we deal with rational functions, okay, the domain is simply put everything that is acceptable, meaning you set the denominator equal to 0, you exclude that. Whatever makes the denominator 0 is out. So in this case, negative 2 makes the denominator 0, so that is out. So you can write simply x is not equal to negative 2, or you can write negative infinity, negative 2, union negative 2 to infinity. This is the interval notation which for it. more importantly as a calculus student rather than just writing x is not equal to negative. So for this function, you do the same thing. Denominator cannot be 0. So what do? You set it equal to 0 and you exclude that. Now to set it equal to 0, you need to factor it. Everybody knows how to factor this. This is very straightforward, the denominator. It's x and x. You want two numbers. The product is -10. The sum is +3. So you want 5 and -2 in any order. It makes no difference. So x plus 5 is 0. That means x is -5. X minus 2 is 0. That means x is 2. Those are out. So x cannot be -5. X cannot be +2. How do we write that? Here's the interval notation. So first understand that this means x cannot be -5. X cannot be +2. Okay. Very straightforward. All right. Here's the next question. Can we say these two functions are the same? There are two functions here. One of them is f of x is x squared minus 4 over x plus 2. One of them is, let's say, g of x equals x minus 2. Okay. We are saying if this becomes this. Okay. And it's important to understand the difference between the two. And what happens, for example, if we graph. Notice you can factor the top, a squared minus b squared. Recall is a plus b, a minus b in any order. So you use that and you simplify. So it becomes x minus 2 under the condition that x plus 2 cannot be 0, so x cannot be -2. Because of that, they are not identical. So the idea is that if you were to graph y equals x minus 2, okay, let's see if I can use a different color. Looks something like this, class. Okay, let me see if I have. So this is 2, 0, 0, -2. And this is the graph of y equals x minus 2. However, if I want to graph this one, if I want to graph this function, which is the same as this, okay? At -2, somewhere here, we have a hole. The coordinates would be -2. Now you put the -2 into that, becomes -4. So the line y equals x minus 2 has no holes. The function f of x equals x squared minus 4 over x plus 2 has a hole. I hope everybody's clear what is the difference between the two. All right. How about this one? Sketch the graph of this function, f of x, 2x minus 3x, 3 absolute value of x. Well, what happens is, because you're dealing with an absolute value, you have to look at the domain. So you have to look at the case when x is larger than or equal to 0, f of x becomes 2x minus 3x, which is minus x. First, understanding the concept. So all you have to do, graph y equals -x. You know how to graph that. Okay. So the second part, when x is less than 0, then f of x becomes 2x minus 3, and absolute value changes to negative x, so you get 5x. So you graph y equals 5x. So that's important to see. So you graph the two pieces and you put them together looking like that. This is not to scale, class, okay? This is not to scale, okay? But I hope it's straightforward, okay? The process is very simple. You come up with two half lines. You come up with two half lines, everybody, okay? Okay. So piecewise defined function. All right, the graph is given for the functions f in red and g in blue. And we want to answer those questions. Those are very straightforward, but let's just make sure we are in good shape. So f of -4, okay. And g of 3. So f of -4. Just for the sake of argument, remember f is the red one. Maybe I shouldn't use the blue color. Let me just change that to something else, just anything. Let me see. Let me pick a different color. So f of -4. That's the point that we are referring to, okay? And then g of 3 is 4. As long as we have those 2 points, I can't imagine we have a hard time with the rest of it. It's just about reading, okay? At what point they are identical, basically points of intersection, f of x equals g of x, okay? So I hope you see that means those x's, if you will, this is where they, happen to be identical. And I'm going to assume we can handle, this is very straightforward, estimate the solution of f of x equals -1, okay? So remember again, which one is f of x? So you set basically one easy way is to draw a horizontal line. Okay, so one easy way, let me see if I can grab different color again. Let's go with this color. Okay, so if you want f of x equals -1, that means y equals -1. You can even draw the line y equals -1 and pinpoint. Those are, I think those are very straightforward. Anyway, so -3 and 4. So there are methods of finding. F of x is decreasing, okay. If you look at the f function is the red function, okay. So the decreasing happens from 0 to 4. I hope it's clear. Okay. In other words, this portion of the graph. Okay, the function is decreasing, otherwise increasing. Now you want the domain and range of f of x. Do the same thing that I did before along the x-axis and along the y-axis. Okay, you see what it covers. Okay, along the x-axis from -4 to 4, and along the y-axis from -2 to 3. That's pretty straightforward. Okay. Let's see. So we are looking at the red function, the f function. Okay. So it covers anywhere. If you look at this last one, this covers here. To here along the x-axis, and you can figure out along the y-axis from here to here. And so you can see what's going on, and you can figure out the domain and range for g of x in the same manner. I wouldn't worry about that. Okay. And very straightforward for the g, the blue one from -4 to 3 is the domain. The range seems to be from 0.5 roughly to 4. If by any chance that 0.5 you read it differently, it's okay, it's not that big. Let's look at the last question of the section. Here's the function. You want to see where the function is increasing, decreasing, constant. Okay. So where is the function increasing? As you can see, from -4 to 0, this portion, the function is increasing. Where is the function decreasing? So take a look at the portion. So that's the answer for the first part. Here's the function decreasing. Look at this portion. And look at this portion in green. And therefore, from -6 to -4, union 3 to 6. Notice the endpoint is not included. Finally, where is the function constant? Okay, from 0 to 3. That's very straightforward, class. I hope it makes sense to everybody. I hope everybody is comfortable with the concept.